Sana rin mo po ay o ano siya sa 3D?
Oo.
Sama. Okay, so, naramakan siya.
Sa mga sa. Hello, good afternoon.
Yes, sir. The noise that we sent to us.
Yun, sir.
Afternoon, sir.
Kumusta mo siya? Nara mo sa inyong balay? No, thank you. Nara mo sa inyong balay? Or na mo sa school? May i-prepare siguro ron nga program para sa mga teachers, no? Mo rin nakakita ko na ito gahapon nga naigi o ni mga tables dito sa covered court. Part ba mo sa kuan? Kining mga program dito? Okay. So this meeting we're going to discuss first, no, katong topic sa load calculations. So let me share to you my screen. So let me share screen. So now, okay, so makita na ninyo ang kuan, ang screen.
Yes, sir.
Good. So I think this is also found in your notes, no? Katong lecture notes ninyo. So if you have it, then you can also open your notes to this page. So in the previous discussion, we have in the design of the different types of footings, no? Starting with square footing, katong rectangular footing, and footing subjected to axial plus bending in one direction. Ang atong gikuha dito, ato lang ipang assume ang mga column load, no? So we assume that the column load already known. So but in actual practice, we need to compute the column loads. So this is this topic we will be introduced on how to estimate or compute the column loads. Matransmit nga to sa footing, no? So in the figure you have here the framing plan of a building. So ato lang ikuan for simplicity, this is the typical second to roof deck level framing plan. As you can see in the elevation on the vertical framing, so nakakay second floor, third floor, fourth floor, third floor, roof deck level, no? Pwede na pa siguro gusto mo sulod. Okay. Sige. So ato lang i-assume nga typical na siya from second to roof deck level, no? Mamo ni siyang frame. So the figure below shows typical framing plan of a four-story building. The dead load consists of 1.2 kPa of floor tiles and cement topping. So this combination already. Then 0.6 kPa for ceiling and other suspended loads. Then 0.75 kPa for interior partition walls. Then 1 meter high, 0.15 meter thick exterior perimeter walls. So kanira dire, no, sa libot sa building. Then service live load is 4.8 kPa on all floors. Story height is 3.5 meters. So let's compute the design load for column footing C1, C2, C3, and C4. No? So ang mga member sizes, let's assume the floor slab thickness to be 0.15 meter thick. The stair slab thickness 0.15 meter thick. Then beam B1, B2. So these are the B1, B3, B4, B5, B6, B7, including the cantilever beam CB1, CB2. Let's assume the size to be 0.3 by 0.6 meter. And for beam B8, ano yung B8? Asa mo ni siya? Ano siya dire sa no, kanidering location. So 0.2 by 0.6 meter, then beam B2, that is 0.2 by 0.4, and the column, let's assume to be 0.4 by 0.5. So the 0.4 meter dimension is parallel to the x-axis, then 0.5 meter dimension is parallel to the y-axis. So in this discussion, I will present to you at least two methods, no, for computing the load carried by the column, which will ultimately be transmitted to the footing, no. So method one is by tributary area method. And the second method, no, kita na to dire sa after the solution, you have the beam girder reaction method. Well, kamo na human na ba mo og reinforced concrete design?
Yeah, I mean, from last sem, sir. Yeah, nasa middle sem.
Naalam mo yung last sem. So sa last sem, isa man yung maestro,
Si Engineer Maratas, sir.
Engineer Maratas. So I hope sa last semester ninyong reinforced concrete, naman tayo laboratory, di ba?
Yes, sir.
So sa inyong gihimo sa laboratory, were you required to design a entire building?
Sir. Mura rin sa tanang pinataglang sets nga style, sir, ang plates.
So piecemeal na itong inyong kuan. So I think it would have been better had you been required to design an entire building, no? But anyway, so muna yung ato ng gihimo diri sa atong foundation design, ato lang ni siyang review topic, no? Because this should have been taught already sa reinforced concrete design subject. But since I was not sure whether you have discussed this or not, so aron lang kuan ato lang gi-repeat, no? Kani nga discussion. So in the tributary area method, no? So I think you are already familiar with the concept of a tributary area. So for example, if you look at beam B1, no, in the figure, ang iyang tributary area sa B1, kini siya dire, no? Ano ang iyang tributary area? So let's try to shade this. So wala iyang tributary. Siguro gray scale, darker. So muna yung tributary area sa B1. So kung mag-isko tag B5, mo sa iyang tributary area sa B5. No? Sa beam B7, mo na yung tributary area sa B7. Yeah. No? So makuha lang kakatunga sa ano. Now, but here we are interested with the columns. So for column C1, which is a corner column, mo na yung tributary, no? So we just lay out the distance half, no? Towards the adjacent column. So from C1 to C2, kuha katunga diha, no? Then from C1 to C3, katunga sad. Then you have there a rectangle, no? Defining the tributary area for column C1. Kung maaari sa column C2, let's use now a different shade for this, green. So sa C2, mo ning iyang tributary area sad, no? And if we go to C3, gamit yung color. So sa C3 mo sining iyang tributary, no? Then for C4, which is an interior column, I think that one kita naman nato gi-shadingan naman kani siya nga area mo yung tributary area, no? Now for C7, kay cantilever naman so ma-include na interior diha, no? So mo na siyang tributary area sa C7. For C8, mo siya ang iyang tributary area. So it's not that difficult, no, to identify sa imong tributary area for a particular column, no? Oops. Wala siya, no? So once you are able to identify the tributary area, ang imo lang buhaton na is to calculate all the loads which is within or included in that tributary area. Like for example, if we look at column C1, no? So ang kaning portion sa slab fill, no? So kung pito na yung pila weight niya ng part sa slab, kaning part sa beam B4 and part sa beam B6, then even part of beam B1, no? Like kanang B1, it is located at the midway between C1 and C3, no? So 1/4 of B1 will be part, no, sa tributary area sa C1. Marita sa C2, so tributary area will include a portion of slab S1 on the left side and a portion also of the slab S1 on the right side. You have beam B4, no, on its side and beam B7. Okay? So to calculate the weight sa tungkuan, it's just unit weight multiplied by the volume. And volume of concrete will be simply the cross-sectional dimension, the width times the height, and you multiply it with the length. So maura na siya ang mga basic nga principle. So, as regards computing the weight of the slab sa beam o sa girder, sa column, no? So length times width times height, okay, or width times height times length. Now for the uniformly distributed load, example sa kaning naaman tay kaning dead load, for example, 1.2 kPa sa floor tile cement topping, so you just multiply 1.2 kPa by the area, no? Area which is affected, no, by the floor tiles and cement topping. Yeah, so swinged ceilings, ilawom sinisiya, no? So you just multiply this value of 0.6 kPa by the area which is affected. Now for the perimeter walls, of course, ang perimeter wall, pag-compute na to na, ano, so you have the cross-sectional dimension, 0.15 times 1, then multiply that by the length of the wall, then multiplied by the unit weight of masonry, no, which is usually taken to be 21.2 kilonewton per cubic meters. Okay, so let's remove the other shades. Let's focus now on C1. Ito na siyang i-print screen. Screen. Paste. And then crop image. Focus na diri sa C1. So, mo na siya nga ito mga calculation. So for dead load, you have the slab S1, portion of slab S1, then portion of B1, B4, B6, no? Then wall along grid line 3 and wall along grid line A. Then flooring partition, you have the ceiling load. Okay, so for the slab, no? So I'll just explain this in detail, then I think for the rest you can easily, because the calculations are based on the same principles, no? So no need to explain each and every line, no, sa atong solusyon dere. So ngari lang sa primero atong explain og maayo. Now, for example, sa slab, no? So 23.6, that is the unit weight of concrete. This is the unit weight of concrete, then multiply that by the slab thickness. So kaning maybe I'll just use a rectangle per point or to highlight, no? Asa nga kung i-refer nga value. Okay, so that 123.6, that is the unit of concrete, then 0.15 is the thickness of the slab. And this quantity, no? Ano siya ang slab dimension parallel to the x direction. So you have 4 that is half of 8, then plus 0.2, which is half of the column dimension, then you subtract the width of beam B6. So it should be clear dimension, no? And kani siyang sunod. So 3.5 is half of 7. So that's 3.5. Then plus 0.25, which is the half of the column dimension in the y direction. And minus na to 0.3, which is the width of the beam B4. And minus half of the width of beam B1. So 0.15. Okay, for beam B1, so 23.6 again, that is delineated concrete. Then multiplied by half of the width of beam B1, no, which is only that part belonging to the tributary to column C1, because the other half now belongs to C3. Then times 0.6, that is the height of the beam. Then kani siyang 4 plus 0.2 minus 0.3, that is the net length, no, of the beam. Okay. So similarly, we have for beam B4, beam B6, united concrete times the cross-sectional dimension times the length of the beam. So I think it's not difficult for you to follow this one. Compute the length. No? So don't memorize anything, just understand, no, what we are doing here. And for wall along grid line 3, so for grid line 3 is this grid line here. So that is along B4, kay Kuandere, no? Kay CHB wall. So you have 21.2 is the unit weight of masonry multiplied by 0.15, the thickness of the CHB wall, then times 1, which is the height of the CHB. Then 4 minus 0.2, this is your length. No? So 4 is half of 8 minus half the column dimension. So you'll get the length of the wall from this point to this point here. Then plus this calculation is for the plaster, no? Plaster. So plaster, we have 0.24 kPa per, so that is kilonewton per square meter of area, wall area. That is on one side, no? Since we assume plastering on both sides, then that would give us 0.48, no? Kaya kanang 0.24, that is on one side. Both sides man atong plaster, so 0.48. And of course, multiplied by the wall area. So kaning 1 times 4 minus 0.2, this is the wall area. So 1 is the height of the wall. Okay. Then 4 minus 0.2 is the length of the wall, tributary to column C1. Then similarly for wall along grid line A, no? So along, that is on top of beam B6. So mo sinidere, no? So kani siyang calculation, this is for the weight of the wall. And this portion here is for the weight of the plastering. No? Now for the flooring and partition, so 1.2 mo ni siya nga value dere. That includes the floor tiles and cement topping, and 0.6 is for the suspended ceiling, 0.75 for the interior partition walls. So ato nang gi-combine, no? Combine na to ang kining 1.2 plus 0.75, no? So for interior partition wall and for the floor tiles and cement topping, then multiply that by the tributary area, no? Tributary area, mga tile na to. So if you look, if we zoom in, no? Kini dire. Zoom in, ano? So unsa man nga portion ang maigo sa tiling. Ang kuha ni ana, no? Under the CHB file, wala na kay tile diya. Di ba? So, kani dire ang imong, if you don't include the area under the CHB. Kanira siya dire, siya, no? Una na ang porma sa iyang area. Eps. So, that one will do. So, muna siya ang iyang kuha, no? So, you have to subtract this portion here. So, there are several ways of doing this, no? I don't have to teach you how to compute area of figures, no? These are just rectangles, so it is really very easy that those of you who don't know how to compute that, you're already lagging so much behind, no? Hindi naman taniin yung pag-compute ng mga area, and the area that involves here is very simple. These are just rectangles. So big rectangle minus small rectangles. You subtract squares. So it's up to you, know how to partition this area to get this area of the shaded figure. So again, don't try to just memorize, no, the solution that I have presented in the notes. No, try to understand what we are doing here. And once you get the idea, no, you can actually solve it your own way, no, because there are several ways to solve an area, no, depending on how you subdivide it. Saan naman to ato? So, ang importante, no, mao na siya ang area nga atong i-solve, meaning atong calculation dire. So don't get lost on the details sa mga numbers, no. Don't try to mo subay-subay ni mga numero dire, no, kung iunsa ni siya pagkuan. Importante ni ana nga sabta unsa i-compute dia, then you can make your own, no, and make your own subdivision, partitioning, whatever. So that is more important. Now for the ceiling load mo gihapon, no, imagine nimo unsa man nga portion ang makisamihan mo, or to i-multiply nimo sa kining ceiling load, no? Ceiling load nga 0.6 kPa. No, mo man siya nga atong ceiling load. 0.6 kPa. So you have here the gross dimension, then minus the area occupied by the column, because of course area within the column you don't put the ceiling, no? Mangisa may kaliri scale sa column dili within. But it's just a matter of common sense, no? And I think your knowledge also in estimating is helpful, no? For example, how do you estimate the amount of tiles? So you have to compute the area to be tiled. Okay, this is the same thing here. And for the total floor dead load, so we just add, no, from item 1.1 to 1.8. So we get total 147.19. Now for the weight of the column, so you have the unit of concrete, siyang 23.6. That is unit of concrete, then multiplied by the dimension of the column, 0.4 by 0.5, then multiplied by the height of the column, no? Height of the column. So for the height of the column, 3.5 times 4 man siya. Now to sa elevation, because you want to compute the load here, no? The total weight of the column. So that is pila ka 3.5. 1, 2, 3, 4. Pat ka 3.5 na kay 1 meter height dire, 1.5 meter below the ground floor line to the top of the footing, no? So that's the total length of the column kini siya. So you get 77.88. Now 147.19 is only for one floor, no? And how many floors are we talking about? So kani second floor, third floor, fourth floor, roof deck, so the total of 4 floors. When I say multiply by 4, you get the total tributary weight, no, for all the 4 floors, and plus the weight of the column, then you get your total load. That is at this level, no? Nidiri nga level. The total dead load, yeah. Then next, we compute for the live load. So let's bring the figure down. Okay, so muna siya ang atong live load. So the intensity of the live load is 4.8 kilopascals. Then you multiply this by the area which can be occupied by the live load, no? So again, don't attempt to, I don't like the way some students would try to analyze this one, no? Ilang subay-subayo ni mga figure, kani mga numbers, asa ni 0.25, ganing 0.15, no? So I think the better approach is really to understand first. This one is intensity of the live load and multiply that by the area which can be occupied by the live load. So katong area nga gi-occupy sa CHB, naa pa ba kay live load diha? So use your common sense, no? You don't have live load sa area occupied by the CHB, no? So katurang clear nga area, no? Katurang clear nga area mo ra to siya ang posible nga ma-applyan og live load. In the same way nga ang katong clear nga area surface sa imong slab maura sad so siya ma-tile nimo, no? Kaya di naman mo i-tile ang ilawom sa CHB, di ba? Ang tile bubangga mo na skilled sa CHB. Okay. So what you will require here are basic nga mga kuan and a lot of common sense. Okay? So this is for one floor, 69.56. Then you multiply that by 4 since there are 4 floors. So you'll get your total dead load and your total live load, which is to be the one that will be used, no, in designing the footing. So mo ni siyang mga values ang ato rang ipang-assume sa previous nato nga mga examples. Karon kita nato kung saan sila pag-compute. So that's it. Then for column C2, a similar procedure, no? Similar procedure will be applied. Rin na sa atong tributary. Ang tanan nga masuod niini nga ini siya rectangle kay. All that is included within the tributary area will be accounted for. No? Just take the inventory and so masuod din ang area. So half of B4, 1/4 of B1 this side, 1/4 of B1 on the other side, half of S4, half of S1, half of B7, entire column C2, no? Okay. Then for the CHB, will be only along this side, no? Lamang tayo CHB diri, no? So marira sa exterior, ora na siyang CHB. And for the area which will be tiled, no? So kanira sad nga area. So kuan na diha, koto bra diha kilid sa CHB wall, it does not include the column. So you subtract the space occupied by the column in computing your area, no? Siya, no? Okay, so again, a bit more. Oro na siya ang sa imong tiled, no? Tiled nga floor. O oro na siya ang sa ceiling, di ba? Sa live load sad, mo oro na nga area ang involved. No? So you give the principle here. So any questions? Wala ba pangutana? Now, even in this case, palitan sa C6 nga naka-stair, so kung ang pong kagatunga diha, no? Siya mo ning iyang tributary. So just apply consistently, no? So everything that will be included within, no, the boundary of the tributary area, you have to compute the weight in that portion. So for example, say stair. So how much of the stair is included within this tributary area? It is not half, no, but this portion is outside, but more of the stair is inside, no? Calculate only that portion which is inside. Okay. Okay, so do you have any problem with that? Ano ba yung mga questions?
Sir, nakakay question, sir. Pero
Sige.
sa kaning
Ah.
ko answer sa
Yung question.
question 1. Saka to siyang beam girder, sir ba?
So,
Kay i-discuss pa nato to, sir.
we will discuss that next meeting.
Okay, sir.
We are already running out of time, no? So I think that's enough for today. Then you can already start. Sa inyong plates. Then Friday, we're going to discuss sa katong beam girder reaction method.
Excuse me, sir.
Sige, sumayin.
Upward. Mo raise na mo ta concerns, sir, pero this is for the other group, sir, sa group 2, under this subject, sir. Kay they'd like to ask daw, sir, like, ganun sila clarify kung sa adjud ang makigmeet nila face to face daw, sir. Kay murag ilang schedule daw is gahapon 3:30 to 5 mateto, sir, if I'm not mistaken. Wala daw ka ato, sir.
So I think we'll meet on Thursday. I think we already met last week, no?
Ang said daw, sir, ang katong group 2, ang nasabutan daw ninyo nga schedule, sir, is Tuesday, then 3:30 to 5 p.m.
Yeah, the problem is I was there, I think, last meeting and they were not there. There was
Yes, sir.
miscommunication. No? Dito sa room, pero umingawan dito. Sige lang, I will post an announcement group nga PTH nga schedule, no? And we will meet this coming Thursday.
Sige, sir. Ang group 2 niya, sir, just to clarify. Okay. Thank you, sir.
So for the Wednesday classes, I've already met, no? So inyong ang face-to-face ninyong schedule is
Wednesday, sir.
10:30, 11:30, no?
Yes, sir.
The class is 2 o'clock, I think. 2 o'clock.
Because,
In the
because sir, basta afternoon set, sir, of the same day. Yes, sir. Sige, sir. Pwede mo ask one more, sir, question.
Okay.
Sa blank set 1 to 4, sir, ba, di ba, in your instructions nagbutang ka, sir, nga maghimo mi og detailed plans sa katong sa footing, sir, both elevation and plan view.
Yes.
And pwede ba to siya ma-CAD na mo, sir, or do we have to draw manually yapon using straight edge? Or pwede ra ba CAD, sir?
Now, in the solution, you have to draw it using a straight edge, no? But in the detail, you can use your CAD drawing.
Sige, sir. So,
You can also choose to use still a straight edge, but be sure it is a scale drawing. No? Pero pwede sa CAD, sa katong details na, no?
yes, sir. Pero if we body diagrams and kadang mga within the solution is dapat manually yapon, sir.
The hand drawn and handwritten.
Sige, sir. So katong CAD, sir, same na yapon like H3, bataw, sir, like last time sa steel na paper. Or
You draw it in a sheet of bond paper lang, no? Mahal kayo ng A3 bond paper lang. Anyway, it's only a single footing, no? So I think it can be accommodated in a short size bond paper.
sige, sir. Thank you so much, sir. Sir.
So doon na pa ba laing concern?
Ay, sir. Sorry, sir.
Sige, Rona, Dayon.
Day, sir, basta kanang among problem set, sir, kay ang parapet wall, sir, kay sa roof deck, sir, is gyapon siya, sir. Nagid siya sa perimeter, sir.
Oh, perimeter.
Tapos ang sa other floor, sir, sa lower floors na, sir, kay wala na parapet wall, sir.
Nasa exterior wall.
Ang sa exterior wall, sa kaning wall 2, sir, kaning balcony.
Tanahon. Let's see what was. Oops. Let me share first my screen again, no?
Sige, sir.
Okay, so let's open. Siguro to, no? Problems 1 to 4. Okay, so we have here concrete plaster. Asa man diri ang kuan? Wall 1. So wall 1, that is full height, no? Second to fourth floor level. Full height na siya kay kana siya is property line na diha, no? So sirado ni diri nga side, diri nga side. Okay? Now wall 2 mo ni siya sa tubangan. Of course, abli na siya kay lisod kay building. As shown in this section, abli siya, no? Mabuo na siya nga height nga wall. It's not full height, no? It's only 1.2 meter height. So roof parapet, that's all around, as shown here, no? It is top. So photo mo diha, no? That is around the perimeter. So it is only at the lower floor nga full height ang mga walls, no? Along the three sides sa imong building.
Thank you,
Okay,
sir.
so it's not clear?
Yes, sir.
So samtala nga ang rason ni kay kini diri nga sides, no? Diri, wall 1, wall 1, wall 1. These are property lines already, no? So imagine that is building situated on a commercial area, no? Dito sa Colon. So ngarira sa ang frontage niya kanira diring nasa wall 2. So ngarira ka makapamintana diri sa wall 2. Pero sa kilid, si kakilid ug sa likod sirado, no? Firewall. Okay, so what else? Oops. Okay na? Apa laing kuan question? Okay, so kung wala na pangutana, and you're dismissed since I also have a next class, no? Right after this. Maghatag ko nila link. So see you again on Friday online.
Thank you, sir. Happy to see you.
Okay, ayo.